The volume of a solid metal sphere is 24,430 centimeters cubed. Calculate the radius of the sphere. The question gave us the volume of the sphere and the formula for finding the volume of a sphere with radius r. This means that these two are equal because they are the same thing. So we can use this expression that we just set up to solve for the value of the radius, which is r. We can make r the subject of the formula by removing everything that is attached to the r. Now that we have r cubed equals something, we can remove the cube by doing the opposite of the cube, which is cubed root. And we get r equals 18.0002, which is just 18.0 to 3 significant figures. The metal sphere is placed in an empty tank. The tank is a cylinder with radius 50 centimeters standing on its circular base. Water is poured into the tank to a depth of 60 centimeters. Calculate the number of liters of water needed. So we have a cylindrical tank with the metal sphere from part 1 dropped inside it. The radius is 50 centimeters and the height or the depth of water is 60 centimeters. This means that the volume of water needed would be equal to the volume of the shaded cylinder, the blue part, minus the volume of the sphere. To find the volume of the blue part of the cylinder, we need the height and we need the radius, which we already have. The volume of the solid sphere we already have from part 1. So the volume of water needed would be equal to pi r squared multiplied by h, which is the volume of the cylinder, minus 24,430, which was the volume of the metal sphere from part 1. We already have the value of h and r, so all we need to do is just substitute that in. B. A different tank is a cuboid measuring 1.8 meters by 1.5 meters by 1.2 meters. Water flows from a pipe into this empty tank at a rate of 200 centimeters cubed per second. Find the time it takes to fill the tank. Give your answers in hours and minutes. The question says that the rate is 200 centimeters cubed per second. So the unit of the rate is centimeters cubed per second, which is a unit of volume and a unit of time. This means that the rate equals volume divided by time. And if we rearrange to make time the subject of the formula, time would equal volume divided by rate. The question already gave us the dimensions of the cuboid, which we can use to find the volume, and it already gave us the rate. So we have everything we need to calculate the time it takes to fill the tank. The units of the rate is in centimeters cubed per second, so when we find the volume, we should be converting the meters into centimeters. So when we do the volume in centimeters cubed divided by the rate in centimeters cubed per second, we get the time taken in seconds, which we need to convert into hours and minutes. 16,200 seconds divided by 60 equals 270 minutes. And 270 minutes divided by 60 equals 4.5 hours. This means that we have 4 hours and a remaining 0.5 hours. We can convert the remaining 0.5 hours back into minutes by multiplying by 60, which equals 30 minutes, but you should already know that half an hour is 30 minutes. C. The diagram shows two mathematically similar shapes with areas 295 centimeters squared and 159.5 centimeters squared. The width of the larger shape is 17 centimeters. Calculate the width of the smaller shape. If we have two shapes that are similar, this means that we can work with scale factors. If we let x equal the scale factor that converts between these two shapes, to convert between lengths, we multiply by x. To convert between areas, we need to multiply by x squared. And to convert between volume, we need to multiply by x cubed. The question gives us the areas of the two shapes. This means that we can use the area to find the scale factor x. Because if they are similar, this means that 295 centimeters squared multiplied by x squared should give 195.5 centimeters squared. And we can use this to solve for x. Once we have our value of x, we have the value of the scale factor. To keep the scale factor and the numbers as accurate as possible, we will use the value as it is in the square root. The question says that the width of the larger shape is 17 centimeters. We now have the scale factor, so we know that 17 multiplied by the scale factor should equal the width of the smaller shape.